to my channel. Today we are going to talk about structure of atom. I'm not going to go so deep inside for the introduction part. For the top topic, I'll go deep. This is a Dalton atomic theory we are going to study here, and the atom is indivisible particle, and it's called autonomia in Greek, and it's uncuttable and non-divisible. Dalton atomic theory was for 1808. He was a teacher. Then after that, he practiced the Dalton atomic theory. We're going to see what it is. So here in this chapter we are going to learn about the major problem before scientists time where these are a problem. You can read out by yourself, but we're going to go so deep inside this. So subatomic particle theory was able to explain the law of conservation of mass. So the law of conservation of mass, law of proportionality, law of conservation of mass, law of constant composition, law of multiple and proportion very successfully. However, it failed to explain the result of many experiments. Like it was known that the substance like glass or ebonite were rubbed with the silk and fur generated. Many different kind of subatomic particles were discovered in the 20th century. However, in this session, we are going to talk about the protons, the electron-proton discovery. So the great discovery of the electron. So discovery of electron is like a big story of K and Go. So discovery of electron in 1830, Michael Faraday showed that if an electricity is passed through a solution of an electrolyte, if an electricity passed through an electrolyte is a solution which it passes through it, chemical reaction occurred at the electrode. So this is the diagram. You can see this is the diagram of the cathode ray discharge tube. He made this diagram. This is a zinc coating. This part is a zinc coating. This is a fluorescent, the zinc fluorescent coating, and there's a high voltage applied here. This is cathode ray, this is cathode part, and this is anode part, and the vacuum pump. We're going to learn why all of these are present. So he thought that electricity is passed through solution of electrolyte. You know the diagram for electrolyte. You have heard about the diagram, I guess. You have heard that diagram, putting like this one thing, and from here you will put some solutions over here, and the electricity pass. In the 10th you have learned all about this. Now we're gonna let's go deep inside that. Chemical reaction occurred at the electrode which result in the liberation and deposition matter at the electrode. He formulated these laws which you can study in the class 12th. These results you will suggest in class 12. These results suggest the nature of the electricity. So from here we can learn about the nature of the electricity. An insight into the structure of atom was obtained from the experiment on electric discharge through gas. So as I showed the picture, that was electric discharge through the gas tube. Before we discuss this result, we need to keep in mind the basic rule regarding the behavior of the charged particle. That is very simple. That is, like charge repel each other and unlike charge attract each other. So in 1850s, many scientists like Faraday began to study the electrical discharge in a particular evacuator tube. The evacuator tube is this, nothing but this. The cathode ray discharge tube. This is the evacuator tube they're talking about, and known as the cathode discharge tube. It is duplicated in the figure 2.1. A cathode ray tube is a glass tube containing two thin electric pieces of called an electrode sealed in it. The electrical discharge through the gas could be absorbed only at the low pressure. So if you pass the gas through this, if you pass a gas inside this, if this is a low voltage, if it's a low voltage, then it is gonna work. If not, it's not gonna work. That's the principle over here. Sealed through the low pressure gas and the metal called as metal tube. Gases and could be absorbed only at a low pressure and a very high voltage. You can also see it in the very high voltage. The pressure of different gases could be adjusted by evacuation. Evacuation means getting all the gases out and again applying it. When sufficient high voltage is applied across electrons, so if the normal or very high or very low energy is applied through this gas, then it's gonna work. That's gonna say there. And stream of particle moving in the tube, negative, this is negative, this is the negative part. this part is negative and this part is positive. By not these are called as cathode ray or cathode ray particle, and that's very, very important. The stream of particle moving in the tube from the negative electrode to the positive electron is called anode. These were called as cathode ray or the cathode ray particle. The flow of current from the cathode to the anode was further checked by the making a hole. This is making here a hole, this part making a hole here. This O part making a hole. We can check by applying some zinc sulfate. When these rays pass through the anode, they strike. When it passes through the anode, they strike in this zinc sulfate and make a bright spot like this. A very bright spot will come over this, and the zinc coating. So this is actually done in the TV. You know TVs, you'll see TVs. No, in that also it is done. The summary is given here. The result of these experiments are summarized below. The cathode ray starts from cathode and move towards the anode. So how it start? It starts from the cathode and move to the anode. These rays themselves are not visible. So these are not visible rays. So as we can see, this is not a visible rays. These rays are themselves not visible but can be absorbed only with the fluorescent or fluorescent. So I thought the zinc coating. Which one? The television also here. Television picture tubes are called cathode ray tubes, and television picture result due to the fluorescent television coating with a fluorescent film. So that if it's when from the cathode to anode, it move in television, it strikes in the screen of the zinc sulfate coating. So that time we produce the light in the screen. So from that we got. In the absence of the electric or the magnetic field, these rays travel in a straight line. It's not like a wave theory or the wave thing. It is like right straight line. So what we have learned, from cathode to anode it travels, then it uses the television. We are saying that these themselves are not visible and the lot. If in the presence of the electric or magnetic field, the behavior of the cathode ray are similar to the expected from the negative charge particle. In the if you put some gases like electric or magnetic field is passed, the behavior of the cathode ray are similar to the expected from negative charge particle, suggesting that a cathode ray consists of negatively charged particle called electrons. Like how the discovery of electron is complete. How the discovery of electron, if any CBSE point of view is there, you can take this. In this presence of electrical or magnetic field, the behavior of the cathode ray are similar to the expected from a negatively charged particle. The cathode ray behaves like a negatively charged particle, suggesting that the cathode ray consists of negatively charged particle called electron. The characteristics of the cathode ray electron do not depend upon the material of electrode or the nature of the gas present in the cathode ray tube. Thus, we can conclude that the electric are the basic constant of all the bottom. So, we have seen the 5 points, which is very, very important for 5 marks per basic exam point. From cathode, I'm going to summarize it. From cathode to anode, it moves. It is not visible, so it has a zinc sulfate coating, which it strikes on it and make a bright spot. It's also used in television. In the absence of the electric or the magnetic field, they travel in a straight line. In the presence of the electric and magnetic field, they behave like a cathode rays that are similar to that of the negative ray particle, suggesting that cathode ray consists of negatively particle called electron. The characteristic of the cathode ray and electron do not depend upon the material of the electron and the nature of the gas which is in the cathode ray. So let's see the charge to mass ratio of the electron in 18897. British physicists in J.J. Thomas measured the ratio of the electric charge to the mass of the electron. So mass of the electron E by M, that the EM, by using a cathode ray. So we have already shown that cathode ray, and this is similar to that cathode ray. The magnitude of the negative charge particle, greater the magnitude of the particle, greater will be the interaction. So this is very, very, very important thing. This is this part. The magnitude of the negative charge on the particle, greater the magnitude. So the greater the magnitude, example, here's the box. Greater the magnitude will be the charge on the particle. Greater the interaction of the magnetic field, or thus greater the deflection. Deflection is like passing, like going this and hitting some surface or wall. That is called the deflection. So if the magnitude of the negative charge particle, that is the cathode ray, is greater, then the particle greater the magnitude of the charge. So if the negative charge particle is have greater charge charge is also will be greater. Greater will be interaction. Then will be the interaction between the magnetic and the electric field, and thus the greater is the deflection. The deflection also will be greater like this. So what we have learned, the magnitude of the negative charge on the particle, the magnitude of the negative charge on the particle, greater the magnitude of the charge will be the greater the deflection in interaction with the electric or the magnetic field, thus greater is the deflection. So it will first we are going to see the negative charge particle on the particle, the magnitude of the negative charge on the particle, greater the magnitude of the charge on the particle. So if the particle's magnitude is higher, greater will be the interaction with the electric and magnetic field, then the greater is the deflection. What will be greater? Greater will be deflection. The mass of a particle, lighter the particle, greater the deflection. So by the taking of the mass, if there is a lighter particle like a proton less than micrometers, like a thousand Dalton small, then it will be like a greater deflection. The strength of the electric or magnetic field, the deflection of electron from its original path increases with the increase in the voltage across the electron or the strength of the magnetic field. The voltage increases across the electron or the strength of a magnetic field. If the strength of the electron or the magnetic field, the deflection of electron from its original path increases with the increase of the voltage. If the current supply is high, there will be increase in deflection of the electron across the electron and strength or the strength of magnetic field. When only electric field is applied, is the important point. If only electric field is applied, the electrons deviate from the path and hit the cathode in the A point. So it we are going to say that it going to strike in the A point. If there is a higher electric field, it will go and hit here. In this part, it's gonna hit. Okay. So when one magnetic field is applied, it's gonna deflect in the C. So we'll see like it's gonna hit in the north pole, it's gonna hit in the south pole. For the MCQ point of view, we're gonna say that. By the balancing the electron and magnetic field strength, it is possible to bring the electron to follow in the absence of electric magnetic hit. So by the absence of the electric and magnetic field, it's gonna hit B. That will be a center point. You wanna explain that? By carrying out the accurate measurement on the amount of deflection absorbed by the electron on the electric field, strength on the magnetic field, Thomas was able to determine the value of E by M. That is the will be the mass to the charge to mass ratio. That will be 1758882 to 10 power 11 CKG minus 1. You need to just mark it up. There is no other way. So it's for simple. I will be saying that 1758820 into 10 to the power 11. Repeat it again. 1.758820 into 10 power 11. So close your eyes and I can say it. 1.758820 into 10 power 11 CKG. Very good, very good. You're doing it great. So where is the electron mass? Is the mass of the electron in kg and E. Is the magnitude of the charge on the electron in coulomb. So do you know that magnitude of charge in the coulomb is not important. Since the electron are negatively charged, the charge on the electron will be minus E. So today's class is getting over, friends. I thought of taking through subtopic. I did. If you liked channel, kindly subscribe. If I get only one subscriber also, I will be putting the videos constantly because it's my passion for teaching. If I get one subscriber also, I'll put all the chapter videos and it's not a thing. Kindly share to your friends. And if you have any corrections, kindly put down in the comment box so I can correct them. So thank you so much for watching my channel. Thank you guys.